Okay, this slide is going to be a review real quick on electrical circuits and electrical currents. Um, we talked about this last year pretty extensively, okay? So we're going to talk a little bit about electricity. Um, Remember, we have two types of circuits that we want to talk about. We have an open circuit, and we have a closed circuit. Now, remember the key thing to this when we're talking about it is an open circuit means that electricity will flow. The path of electrical flow is open. A closed circuit means that the electricity is not going to flow continuous. Because remember, electricity has to have a continuous flow. And this occurs because of the movement of electrons. Remember, atoms have protons and neutrons located in their core, right, in the nucleus, and they have electrons, right? Those are the three subatomic particles. Electrons, protons, and neutrons, where the protons and neutrons are inside the nucleus and electrons are outside. What that means is, if I had an atom, right, my protons, remember protons are positive, neutrons have no charge, and electrons carry a negative charge, right? And protons are a positive charge. So my protons and my neutrons are located inside the nucleus, and electrons are located outside of the nucleus. And remember, it's this movement of electrons that generates electricity. So, with that said, we have an open circuit and a closed circuit. Now remember, we must have some type of energy source, whether it's coming from a transformer, like the big boxes at electric companies, or even if it's coming, say, from a battery, right? And what ends up happening, let's say we have a battery, and then we have this path of the wire, and then we have a light bulb, okay? And then let's throw a switch in here, right? Because we know we often control this with a switch. So let's throw a light switch in here. Okay, so we have a lot of different things here. If I turn the switch, I flip the switch to an on, that's gonna basically put a connector between these wires, and it allows for an open circuit. Okay, it's an open circuit because what now can happen is these electrons can flow all the way through the circuit, and we have electricity. Now, if I were to do the same type of thing over here on my closed circuit diagram, I have my battery, and then I have this wire, with my switch, my light bulb, but let's say this time the light switch is turned off, right? Well, I no longer have a continuous flow. And in order for me to have um, electricity, this is important, I must have a continuous flow. Okay, there must be a continuous flow. If there's a break anywhere in there, then electricity is not going to be generated. And in that, on the circumstance, what ends up happening is you have what's called a closed circuit. And again, it's closed because the electricity isn't flowing. So again, what we're doing in this is we have the movement of electrons, right, through the wire, but all of a sudden, if it hits the where the light switch is, if that circuit, if it's turned off, that circuit's closed, and so we're not going to have any kind of electrical flow. Now, one other thing I want to really point out, or remind you of, I should say, we did this a lot last year, but one thing I want to remind you of is there are basically 4 types of energy transformations that we want to talk about. There's some other types too, but we're going to talk about, and we did this last year, we have chemical, we have electrical, we have light, and then our fourth one, which all of these produce, is heat. We have chemical, electrical, and light. And what I need to keep in mind, as we did last year, remember, batteries operate because of acids, right? We have acids that, and the hydrogen start getting activated, and then we have this flow of electrons. So our battery has chemical energy. But then that energy is transferred into electrons, and so those electrons are going to travel down the wire. Therefore, we have basically electrical energy through the wire. And then we get to the light bulb with those electrons, and it produces light. So we have chemical energy in the battery, we have electrical energy in the wire, and we have light energy in the bulb. And remember, no matter what, we're always giving off heat. There is heat being given off from the battery, right? You guys fill the battery packs on your on your computer chargers, and you can feel the heat on them. If you were to take that rubber coating off, you would feel heat in the wire. And then you all know that a light bulb gets hot, so you have heat there. All right, these are the energy transformations. So we basically, in this circuit, we have the chemical energy being converted to the electrical energy going down the wire. And then once it hits the bulb, it's converted into light energy. And then it hits the wire again, and now we're back into electrical energy in the wire. Okay, electrical. And then obviously we're back to the battery where we have chemical. Okay? So the 4 types of energy transformations, again, last time is chemical, electrical, light, and then all 3 of those generate the 4th kind, which is heat, where chemical is in the battery, electrical is in the wire, light is in the bulb, heat is basically being given off by all of them. Now, one quick thing that I want to finish talking about, one next thing on the slides is there's 2 types of things that we have when we're talking about electricity. We have conductors and we have insulators. Okay? Remember that a conductor allows the flow of electricity. And the reason for that is because there is not much resistance. However, on insulators, there is lots of resistance. And therefore, since there's a lot of resistance, then electricity does not flow easily. electricity does not flow easily. All right? So some examples of conductors would be all kinds of metals. Basically, all kind, basically that's what you're dealing with, metals. Okay, so things like copper, right? Aluminum, iron. Okay, so these kind of things, copper, iron, aluminum, those are all going to be, any of your metals are going to be conductors. Insulators, examples of insulators. There's things like plastic, wood, rubber, those would all be examples of insulators, right? Think about it. If you take and if you have an eraser, right, made out of rubber, it's not going to conduct electricity very easily, right? So that's an insulator. If you look at your computer charger or any kind of cord to an appliance, then you're going to have, you're going to have an insulator. You can touch that rubber part that's plugged into the wall and you don't get shocked because it's an insulator. But if you didn't have that rubber coating on there and it was metal and you grabbed it, it would shock you. Okay? So, again, if we talk about, we have open circuits and closed circuits, and we have an open circuit means that the flow of electricity is open, can be used. And if we have closed circuit, that means the electricity is not going to flow very easily. Conductors, again, are good, allow electricity to flow. Insulators do not allow electricity to flow. Okay, and then there's a couple things that determine resistance. Remember, how do we determine resistance? Things that will determine resistance are the length that the electricity has to travel, so like the length of wire, the thickness of wire, the temperature of the wire as well will determine how easily something flows. And then the fourth thing that's going to determine how the resistance is going to be the type of material. So all those things have to be taken into account. Lastly, we have parallel circuits and series circuits. And I want you to remember that on a parallel circuit, that means that there are two paths in which the electricity can travel. Right? If I have my battery, all right, there are two paths. It can go this way or this way. Right, parallel two lines, so two paths. And in a series circuit, I'm only going to have one path. Okay, so one path in a series and two paths in a parallel. Okay, two paths in a parallel, one path in a series. Hopefully this helps you with the electricity review.